So this is a Rapido 00 scale Jones Goods 460. It's in early LMS livery, and I'm going to have a look at fitting a high quality non-sound DCC decoder to it. So they're beautiful models, they've got really nice mechanisms, just running on an analog at the moment. So perfect candidate for a high quality decoder. So they've put the decoder socket in the tender, which is quite common. A lot of Bachmann locos work this way as well. I think actually it does unplug, so we can just disconnect that from the rest of the loco. Make this easier. So there are 4 screws, 2 behind the axle and 2 you can just see there in front of the coupling holder. Taken the screws out already, so it just lifts off. Really nicely presented. And then you've got the 21 pin blank plug in there already that it needs to have in there if it's running on analog. So I'm going to get that out. What I'd like to do is just gently lift it up from each side and just sort of ratchet it up so that it comes out without bending the pins. So we'll do that off camera. Okay, so I've carefully just sort of lifted at that edge and then gone round and then lifted at that edge until it's released off the pins. Oops. And there we go. So manufacturers quite like the 21 pin because it's in theory you can only get it in one way round. You can see the missing pin in the corner there on the blank. And it doesn't have trailing wires. So I think this model's probably using about 6 of the wires, 6 of the pins. 2 track feed in, 2 motor and 2 for, I think there's a firebox glow. Yeah, looks like it. So they're not using all the pins, but it is a nice, easy and secure method of putting a decoder in. So there we are, that's the Lenz decoder in there. And the Lenz decoder is a completely NMRA compliant decoder. It supports 9,999 addressing, 28 and 128 speed steps, and it also has a few bespoke features like ABC braking, railcom, and it supports the older braking on DC method as well. So they also like to support older technologies. Okay, so I've reassembled and reconnected the tender, dropped the cold load in as well just for completeness. Now I've set it up on a programming track. This is a bit built-in braces, but it's a nice way to check out the loco in a safe environment. The programming track is low power and only energized to do reading and writing. So let's quickly go program track. We'll do the loco address, so it sort of checks out the chip as well while it's doing it. Come up as the standard address 3. I'm going to clear that and let's do 1792 and send. See it ticking as it sends information. There we are. So I'll set up the driving throttle for 1792. Right, so the programming track on the Lenz system is not live, but the main track is live with a potential of up to 5 amps, so that's why we check things out before we give them full power. And there we are. So the chip is just on factory settings, I've not done any programming. You get beautiful running. And there we have the firebox glow. So the firebox glow is activated by function 1 on the chip. They actually have 2 LEDs in there, so there is function 2 operates the yellow and function 1 the red. So I'm going to do some programming to make that more sensible. So what I've decided to do is actually to put both the functions to function 0. So I'm going to turn function 0 on so we can probably see this in real time as I apply it. So function 0 is the headlamps, and it has 2 components, so it's forward and reverse. So we need to change 2 settings, and this is called function mapping. So what I'm going to do is go into programming on main. You can do this on the programming track as well. I'm going to go to CV33, which is function 0 forward function map. At the moment it's on a value of 1. Going to clear that, and I'm going to put in a value of 12. Send, and there we are, the 2 lights have lit up on the forward direction. If I escape out, you can see that's just on the forward component, so as I change direction it goes out. So I need to do function 0 rearward component. So this is all a bit academic, you don't really need to do this, I'm just playing around now. So I'm just going back into programming on main, and for the rearward component it's CV34. And also to a value of 12. You can see that the lights are both on steady at the moment. I'm just going to program something to make them flicker. Sorry, I just needed to check some values. So it's CV62, and we want to write in a value of 22. You can see they now flicker. So these chips are designed to go into a multitude of different loco with lots of different lighting effects. You wouldn't necessarily want headlamps or cab lights flickering. So they have this customizability that allows you to set them up in this way. So now, yeah, function 0 is the firebox flicker. So I felt that that was a little bit unrealistic on that setting, so I'm going to change it to a different one. There are different sort of frequencies, so I'm going to change it to 42 this time. Now I think this is going to be better. There we are, that's a bit more realistic. So there's always options. So the fact that I've been able to read CVs whilst out on the driving track is due to a thing on Lenz chips called Railcom, and with a Railcom enabled system it allows you to go in and read CVs on the main track without having to transfer to a programming track. So we'll just read the CV, the identity of the chip there, and it says it's 99, which is the code for Lenz. So Railcom is a handy thing for doing programming on the main. So it's not mandatory that you do all this programming, I am just playing around with some features. So it's just nice to move things around. But another nice one is acceleration and deceleration delay. So CV3 is acceleration delay, and it will be set quite low from the factory. If I clear that and put in a higher number, and we'll do the same on the opposite, which is CV4, which is braking delay. So again, it's on a low value to start with. I'm not going to put it to such a high value, I'll put it to around 15. Because braking delay, you want the loco to be controllable and will stop in a quicker distance. So with the acceleration delay there, you see the loco feels like it's got more weight. Takes a bit more time to get up to the maximum speed. So I'm doing that on 28 speed steps. While we're messing around, let's put it on to 128 speed steps. So now we've got the throttle showing 3 digits. Now we have much finer speed steps. It doesn't change anything in the decoder, it just changes what the controller is sending to the decoder. To be honest, in terms of driving, 28 speed steps is as smooth, but you can set it to finer increments on 128. It will still accelerate and decelerate according to the settings in the chip, so the chip itself is smoothing out the motor. It doesn't really matter what the controller is sending to it. That's really nice. If you have changed the settings, you can actually use an override. So function 4 here will put it to direct control from the throttle. So it's quite handy if you just want to do a quick move in the yard, but it doesn't feel very realistic because the loco's a bit skittish. So we'll turn that off and it will return to the acceleration and braking delays. The other function on these chips is quite nice, is shunting speed, which just reduces the speed on function 3 on the chip. Some motors it's not all that noticeable, to be honest. This is quite a finesse motor that Rapido are using. It does run beautifully.